Hello everybody and welcome to this webinar. The topic for today is Tekla Structures and Trimble RealWorks working with point clouds. My name is Lee Snyder, the product manager for the steel segment here at Trimble Solutions USA. I'll be your host as well as a presenter in the webinar today. I'm also joined by David Highland, who's a sales engineer for the Trimble Buildings Field Technology Group, and David will also be presenting to us later today. Before we dive into the webinar content, just a few housekeeping items here. If you have any questions throughout the webinar, feel free to enter those through the chat window that you can see there in the GoToWebinar interface. We'll try and answer those as we can. And then any questions that we're not able to get to, we will reach out to you after the webinar. This webinar will also be recorded, so if you want to share it with any colleagues or rewatch it, we'll send you a link to where you'll be able to do that. So as mentioned, we're going to focus on how you can use point clouds within Tekla Structures as well as a lot of the powerful tools within Trimble RealWorks. What you're looking at here is phase 2 of our Trimble building expansion that's going on out in Westminster, Colorado. So this is a Trimble building that's being built for us, and it's given us a great opportunity to use our Trimble products on that. So we're going to use the content from that project in our presentation today. So quick introduction to Tekla Structures. For those of you that may not be familiar with it, it's a 3D BIM modeling environment, and everything that we do here at Trimble is focused on construction. So we're going to create within Tekla Structures constructible models down to every nut, bolt, weld, washer, embed, rebar, whatever needs to happen to be fabricated, whatever needs to happen to support erection out on site. That's the level of detail that can be included within the Tekla model. And from the Tekla model, you can generate all of your bills of materials, your reports, your fabrication information. It's a 3D database of information for the construction industry. In Tekla Structures version 2018, we added support for bringing in point clouds into the model. That allows you to pick and snap to the points. We can use clip planes to crop to a specific area that you want to be able to view. We have base point functionality, which means that we'll always be able to align the point cloud and the model regardless of the real world coordinates that were used to capture the point cloud. And then there at the bottom you can see a list of the available formats that we can bring into the Tekla model. So as I mentioned, David is representing the Trimble Buildings Field Technologies, and they have solutions that range from data preparation all the way to site layout. So that includes office software, field software, personnel management, scanners and layout equipment, just a wide variety of things to support you in your construction projects. So our focus today will be on point clouds. The way that point clouds are captured are by using scanners similar to what you see here on screen. Trimble has some of the most accurate scanners that are available on the market. Typically each scan is about a 3-minute scan time, which includes full accuracy across the entire range of that scanner. So just to give you a little bit of context, that image down in the right hand corner, we set the scanner up. It was about 300 feet away on the rooftop of an adjacent building, and the scan was so accurate that we were able to determine the rebar size from this scan. So incredibly powerful, very, very accurate. So depending upon the size of area that you need to scan, more than likely you're going to have to take more than one scan. Each scan is like a piece to a puzzle, and the way that we assemble that puzzle is by using a software called Trimble RealWorks. This allows us to process and register the scans. We can analyze and inspect the model directly within the point cloud. We can generate reports and other type of deliverables. One of the things that we'll focus on is how we can pair the Tekla model with the point cloud for interaction there within Trimble RealWorks. And then of course you're able to share, collaborate, and export any data that you need to send or share with people. There are a wide variety of production tools within Trimble RealWorks. We're going to focus on the 3 ones that I have in bold here: the floor flatness reports, the core verticality reports, and the compare to model functionality. And then another solution that we'll also show is Trimble Connect and how it can support point clouds. If you're not familiar with Trimble Connect, what it is it's an ecosystem of collaboration for the construction industry. Regardless of what software you're using or what products you're using, we want Trimble Connect to be a single source of truth for information, whether you're using 2D drawings, 3D models, spreadsheets, point cloud files, it doesn't matter. All of that stuff can be stored within Trimble Connect so that everybody working on the project can go to one centralized location and to get the data that they need. And then you have full access to that data on any device that you want. We have desktop application, web application, mobile applications, and then also a HoloLens application. So we want you to have access to the data wherever you are using whatever device that you have. So there's a couple of workflows that we're going to discuss today. I'll just give you a brief overview of those before we show these how they work within the software. So David has gone out and created scans of that Westminster project. He's registered them within RealWorks, and then he sent those files to me. And then there's one of two things that I can do with those. I can bring those directly within Tekla Structures and begin interacting with the point cloud in my model, or I can bring it into a program called the Point Cloud Manager, which is a free download available on the Tekla warehouse. That's a standalone point cloud viewer and allows you some real basic functionality as far as creating measurements within the point cloud and even just doing some real simple cropping of the point cloud. So nothing near to the level of what Trimble RealWorks can do, just real basic viewing and manipulation of the point cloud. And then once we're done doing what we need to do within Tekla Structures, of course, we can share that into Trimble Connect so that people that don't have Trimble RealWorks or Tekla Structures can view the model, can view the point cloud, and collaborate with us in a 3D environment. The other workflow that we'll discuss, again, is David has gone and done the scans. He's brought those into Trimble RealWorks and registered those. I can then export the model from Tekla Structures to where David can import that into RealWorks and then begin to do some interaction and comparisons there as he will show in his portion of the webinar. So to begin our workflow, David has gone out and created scans here, as you can see, of the first two floors. So all these are the TZF files that he went through and created and sent those over to me, and then I can do one of two things at this point. I can import these scans directly into Tekla. This is Tekla Structures right here, where you can see that I have the 3D model. I can insert the point clouds and begin interacting with them and the model at this point. The other thing that I can do, and that's what I'm actually going to mention first, is introduce to you the Point Cloud Manager. What this is it's a standalone software. It's available for download on the Tekla warehouse, and it allows you to insert point clouds into it and to have some really basic tools as far as manipulating it. So before you bring it into Tekla, you could bring it into here if you want. You don't have to, but it'll allow you to view it, pull some dimensions. And then what I'm going to do is even crop this down just to make sure that I cut out any excess stuff. So it just has some really basic editing tools to the point cloud, but nothing near what we're going to see David show us in RealWorks as we get there. So if I open up here the Point Cloud Manager, I can just go ahead and launch this project. Just to save time, I've already gone through and inserted these, and let me just change some of my visualization here. So if we take a look, these are all of those scans that have been loaded here into the model. So here's the bulk of the structure that's there. Again, those are the first two floors that we're going to talk about. You can see the cranes, and then you can see the other, the existing Trimble building that's already there that we're going to combine with this little walkway here right in the middle. So as I mentioned, there's a few options up here. We have some measuring commands. If we want to do those, we can come in and we can create clip planes. We can adjust the size and the density. For our purposes today, what I'm going to do is I'm going to just shrink this or kind of crop this down to just include the structure so that I don't have to bring in all this excess stuff. I could if I want, but just to make it more easy to view, I'm going to just eliminate that. So if I come back over here to the home, I can come over here and just hit this select area, and you'll notice what it does is it's just going to bring me in 4 basic clip planes. So nothing too fancy, but just 4 clip planes that I can just click and drag and start cropping. So I'll just do this to the 4 sides that are right here just to eliminate some of this excess stuff that I don't need or don't want to see. And let's see, let's do one more over here. And I'll zoom in a little closer, make sure we got everything. So that's a lot better, a lot cleaner. Let me just drag this guy over just a little bit more, and then we're good to go. So just doing some basic cleanup, and then what I can do is I can come up here and click on export, and then export this just as one file. So let's just call this cropped. I have a few different options here. I'm just going to save this as a LAZ file, which is something that Tekla obviously can read in, so I'll just go ahead and click on save. it exports it, and then I can then insert that into my Tekla model. So now that we've exported that crop section, let's go ahead and jump into Tekla Structures. So we're back here again into the model, as you can see here. And now what we can do is we can come over here to this cloud icon and we can import this into the model. So I'll just go ahead and browse to the file. Here's that cropped file that we just created. When David was out on site, he geolocated all of these scans. So we've created a base point that aligns with that so that when we insert the point cloud, it lines up with the model. So I'll just go ahead and click on Attach Point Cloud. It will go through, it will then process the file, and then I can come in and just set that to visible here within my Tekla model, and then I can see that there kind of in this shaded area. So for additional clarity, let me just go ahead and turn off the model just so we can just see the point cloud. So we can see it there. Again, we can spin this around, zoom in, and take a look at different things. And so here we can kind of go in two different workflows. If you don't have a model already created and you receive a scan and want to create a model from it, then you can begin snapping to this and just modeling in certain things. So for example, if we wanted to turn this into a plan view, and let's say that we wanted to model in this concrete core right here, for example, or if we wanted to model in beams or whatever the case may be. So I'll just go ahead and activate the concrete panel command, and then here you can see that I'm just able to snap to these points. So I'll just go ahead and pick these corners, come on over here, and then as soon as I'm done, let me grab that point again, come on down here, and then you can see that this will be added there just as if you had manually modeled it. So we're just using the point cloud to be able to come in and trace. So we already have this modeled in because the project already existed, so we can go in and compare those. But if you want to snap to and model to this within Tekla, you can easily do that using our modeling commands. So kind of the other workflow is that if you already have the model like we do, you can use this for comparison. So let's say that we turn our parts back on, we can see the model. We can go in kind of floor by floor or elevation and see if there's anything that's missing in the point cloud scan. If I zoom in here, you can see here that some of this information was not installed when the point cloud was done. So it's just again a way to come in and visually inspect that. So nothing near like the comparison between the point cloud and the model that David is going to show us in RealWorks, but just a easy visual verification here within Tekla Structures. So what I'm going to do right now, I'm just going to come in and turn off the point cloud. The next thing that we want to show in this workflow are some really powerful tools that you can do within Trimble RealWorks, which is where you can bring in the point cloud, have a lot more interaction options there, and in addition you can do some interaction between the point cloud and the 3D model. So here what I'm going to do is just export a couple files that I'm going to send to David so that he can process those within RealWorks. So as we've seen, we just did the scan just on the first two floors. So what I'm going to do is just come in here and filter out just the level 1, go ahead and hit modify there. And then I'm just going to window highlight this area right here, and then this is what I want to export to David so that he can compare this in RealWorks to the point cloud scan. So I'll just come up to File, Export, and go to 3D DWG or DXF, and I'll just give this a name. So let's go ahead and I'm just going to call this the first two floors, and then I'll just include some of the settings that I'm going to include in this export just for clarity. We know what we use. So I'm exporting this as faces, as you can see here. My part accuracy, I'm going to set this to high. You can set it to normal, it'll still be okay. I'm not going to include the bolts in my selection filter. I don't have any of the secondary information. If you want to include the cuts and inner contours, then that's fine. I'm just going to export these selected objects here, and I'll go ahead and click on Create. And then I can send this over to David, and he'll show you what he's going to do on his side within RealWorks. Alright, so one more export. Let's go ahead and also I'm going to send these concrete cores that we want to send to him as well. So using the same settings, I'll just go ahead and change the name here to cores, hit apply, click on create. Now I'm going to have two WG files that I can send over to him to be able to use within his process. So I'll package these up and pass it over to you, David.
Thanks, Lee. So we're going to take a quick look at the point cloud here. So here is just a quick overview of the steel structure that Lee was working on. You can see we did a number of scans from a neighboring building, number of scans from around the building as well too. Let's go to a quick top-down view. If we go, we can turn on the station names as well too, so you can kind of get an idea of how many scans we did all together. So we did 14 scans. This was carried out with the TX6. For this project we used no target, so everything was done with the plane-based registration feature inside of Trimble RealWorks. So I think processing time for this probably was about an hour for everything to register together. Capturing the data, these were 3-minute scans on the TX6, just to kind of give you a quick overview. We can also do a quick zoom in as well too. Here just to show you the level of the detail that we're actually capturing on the steel itself. So if we wanted to create or capture a quick measurement, so if I wanted to get the height of this beam, I can pull this. Accuracy wise, you're looking at anywhere from a 1/16 of an inch all the way to 1/8 inch, so really tight tolerances on the TX6 scanner. So I'll just kind of position myself, give you a little bit of a better overview. We can also clean up the point cloud, so if we just want to focus on this new section of the building, we can cut out the neighboring surrounding area and just focus on the area of the new construction. Again, you can actually even see the crane, and we can clean it up a little bit better and download a new section. I've cut out one earlier on previously, so I'll just upload that one just to save some time. And here's a cleaned up version where we've actually removed the concrete crane in the background. So I'm just going to come in here now and I'm going to import Lee's 3D file from Tekla. And then once the model is imported, I can see it overlapping with my point cloud. One thing to note that this point cloud was georeferenced earlier on, so it is on the same coordinate system as the Tekla structural model. And you can see how we can maneuver around the point cloud and select different objects in the cloud as well too. So I'm just going to go to a parallel view, switch it to a front, and then from here I'm going to select everything because these are all separate objects. I'm just actually going to make it one object so you can see how I can highlight everything. Once I have everything highlighted, I can switch to model, and now I can come in here to merge it into one entity just to make it easier for me to maneuver around the 3D object. And this also helps with the rendering process inside of RealWorks to navigate around the actual object, so you can see how quick and easy and smooth it is. So once I have it set to an object, you can see I named the 3D model mesh in the bottom. I have my point cloud turned on. I can go to the inspection tool within inside Trimble RealWorks, highlight both of them in my list window. Again, the green is the point cloud, the red is the 3D model. Then I can just hit preview and you can see how it's computing against the structure, and it's going to create a heat map deviation against that structure. So a couple of the benefits we'll see there once the results are computed. I suppose first of all, I can see the missing steel items from the point cloud because of the color code. It doesn't have anything to compare it against, so you can see the distance is a lot further, and that's why the color sticks out a little bit more vibrant. But we're actually going to ignore that part and just focus on the 3D model of what we have relative to the point cloud. So I'm going to filter in my inspection. I'm going to filter it into, say for example, for 3 inches, and you'll see that top part being removed. And once I do that, now you get at the point cloud that's just relevant to the 3D model that we have uploaded. And if I turn off the model, again, you can see blue means it's actually fitting the model really well. So I'm pretty happy with the results overall. There's a lot of blue in the model with regards to the steel. I can see on the concrete there's a little bit of color or deviation on the model, and a small little bit down here on the southeast side of the building. I can just export this out as an inspection cloud, and again, if I turn off all the points, you can see here where when we hit create earlier on, it creates this inspection map. And I'll just select the inspection map. I suppose one thing to note as well too, another benefit to to this process is you can actually filter out just the point cloud. So it's a great way to extract out the steel and remove moving objects from the point cloud. So a great way to clean it up. So again, I'll just switch it to the cloud color, so now I can actually see what's actually happening out in the field. I can turn on my 3D model. I can now turn on the 3D analyzer tool so I can see what those colors represent out in the field. And again, I can just turn on the model really quickly. And if I hold down on the N key, N for November, on my keyboard, I can do this autofocus. So this is a great way to really inspect what's happening between the point cloud and the 3D model. And then I can just come here and I can get the ruler measurement tool, and I can pull a distance from the face of the flange or from the webbing and get that distance. So you're looking at about 1.2, so showing you kind of relevant to that orangey color on our legend. Again, if I kind of rotate to an area maybe on the other side of the building where we have a lot more blue, and if I zoom in, and blue means that it's matching our model really well, so there's no deviation compared relative to the other area. You can see how well the point cloud, both on the webbing and on the flange, meet one another. So again, it's telling us that everything is snapping together really well. And again, if I just do a quick fit to the points, if I zoom in here where the model is, again, you can see it's a very small deviation between the point cloud and the 3D model. So just over 4 mil, which I'm pretty happy with. And again, I can just keep on doing a quick inspection. If I want to check the verticality, I can see all my steel is pretty well vertical in the model. And again, I can turn on the model and do some quick QA/QC, look around. Okay, everything looks to be fitting really well. And I can make the points smaller if I need it as well too, so they're not being exaggerated. Maybe I can even jump down here to where I have a slight little bit of green, or maybe a slight little bit of deviation on the model. And if I actually go to a quick top-down view, or if I turn it to a wireframe, so we can change it to a wireframe as well too, just to kind of give you a little bit more contrast to what's actually happening out in the field. So again, you can keep on doing your inspection. I'll actually show you the model of the core in a little bit more detail, because I did a couple of scans as the building was being progressed, of where we were able to take some interior measurements of the concrete core as well too. So I'll pop that opened up here in a different project that I scanned. And again, I'm going to use the same model that Lee provided from the Tekla structure model. And again, if I just double click on the triangle, it shows you that we did 2 scans inside, and you can see just outside the door where we did another scan, and you can see the embed openings as well too. So a lot of detail captured inside the point cloud. And again, no targets were used. It's one of the benefits of the Trimble TX6 scanner and the TX8 is that we do not need to use targets for our point cloud registration or for collecting the data out in the field. And I'm just going to come over here and I'm going to, again, using that segmentation tool, cut the core up into, I suppose, manageable pieces. Then I can turn on that model of that core and then select both of them using the inspection, 3D inspection. And just use Control and Shift, or Control and selected both of them on my list view in the bottom corner. And then, yeah, you would be running that same process what we did on the steel. Hit the create, and it'll create a new inspection map. That under the file type there you see 3D inspection, so I'll have that one turned on. And then now I can start to see my similar deviation report that we had on the previous outside. What I want to show you here is on the inside of this stairwell is we have quite a large deviation. So if I grab our view cube and if I just focus in on this area here, maybe turn it to a parallel view or it's not as skewed, and I'm just going to push and pull these arrows just to kind of show you what's happening. So you can see there's quite a large deviation here on the stairwell wall. And again, I can take some quick measurements of that deviation just to show you how it differs. So we got 7.6 inches. I can hit download. Again, if I scroll up here to where blue, so blue is probably showing you a closer measurement to reality. We got 10.2 inches. If I just do a quick zoom extend, you can see there's quite a difference between those two measurements. And again, I can turn on that 3D model and overlap it with my point cloud. And you can see the green line showing you the 3D model, and that yellow slash, I just changed it into the cloud color there on the heat map, red is, so you can kind of see quite a large deviation. Looking at the blue, you can see that it matches the point cloud and the model really well. Again, going back to blue means it fits our model really well. And we can push and pull that all the ways through that cross-cut section of our desired thickness. I can change it to a solid as well too. Just kind of show you what exactly is happening. And I can actually record that view as well too under a limit box. So if I was ever to close that, and if I wanted to get that view up really quickly, I can just double click on that view and it takes us right to that physical location. So again, some really great techniques and ways to see that deviation. You can kind of see it a little bit more clear there in that kind of top-down perspective view. And again, to kind of, I suppose, one more area we can focus on is concrete and on the floor analysis. So we have the ability to do the FF and FL analysis. So I'm just going to jump to another part of the same project at a different stage. So you can see now a lot more of the building is progressing. There's a lot more objects on the ground floor. So I'm actually going to jump up to another one of the floors on the 4th floor of the building. And carry out a floor flatness analysis and an FFFL report. And again, you can see the scale of the project that we were able to capture again with the TX6. So a lot more scans, a lot more interior scans now relative to our previous scans. They were more exterior. And if I, again, look around, I can kind of get a good idea of what I want to, I suppose, focus on. You can see I already have an area cut out using the segmentation tool again, which is very powerful to isolate certain areas of your area of interest. And again, I can just turn off the background and the main building and just turn on that area where I have the 4th floor analysis. So if I double click on the triangle, it takes me in, so I'm on the wrong station. So click on the one below, and you can kind of start to see what we've just captured. And I'll just change it to intensity just to show you a little bit more of the contrast. So you can see the level of detail in the actual model. I'm just going to switch it to white just to show you how we can use our sampling tools to actually remove all those objects in the background and just focus on the floor. So I'm going to select the sampling tool inside of RealWorks. I'm going to switch to floor extraction indoors. I'm going to hit show outliners in red and hit extract. After a minute of processing, give or take, you'll see it'll actually auto extract out everything bar the floor. So it's a great way to clean up the point cloud if it's late when you get out to that area to inspect. Again, if you can try and do the analysis before everything is being placed on the concrete, it's definitely a benefit. But I'm just going to hit keep floor, do a quick look around, quick inspection, make sure that everything was removed from my point cloud, bar the floor, and I'm just going to hit create. And you can see down the left hand corner now, it's actually created a new surface for me called floor extraction. And then once that's extracted out, I can just do a quick top-down view. You can see some of the shadow areas. They were objects that were blocking the point cloud or the laser scan. And then I'm just going to come over here and I'm going to do an FFFL analysis first, and I'm just going to focus on just this bottom right hand corner here. I'm going to cut out the rest of the point cloud, and I'm going to analyze this section here. And then once I've got my area nice and defined and cleaned, I'm going to define an area. And if you look down in the bottom right hand corner, it's going to tell us the minimum number of readings, so 107. So again, based off of the standards from the ASTM, I'm going to pull measurement 45 degrees relative to my test area, and then I'm going to pull corresponding readings relative to that overall measurement. And you can see then as I'm pulling those measurements, it's actually calculating the FF and FL for that section. And again, if you look down on the bottom right where it says our total number of readings, we currently have 238 readings in this data set, so we're well over our minimal number of readings. So I'm going to zoom in a little closer just to kind of give you a good overview. That circle that you see in the bottom is where we actually had the scanner placed out in the field. We can see an overview, and what we can do next is create a report. It's going to say that these are all based off of the ASTM standards. Or if I hit yes, I'm going to call it, give it a name. So I'm going to call it project report, and I'm going to hit save. And here I can put in some project specifications. So one thing to note is that this is on the 4th floor, so FL is going to fail more than likely because it's very hard to meet the specifications on non-ground floors. So again, you can see our FL actually failed just because it's very difficult to get the floor extremely flat. And you see when we actually do the heat map in our next floor analysis, you'll see why FL was failing. So I'm just going to close down this application, and the next one I'm going to do is I'm going to carry out a floor inspection. So essentially what I'm doing is I'm getting a heat map of what the floor is actually doing out in the real world. So again, similar to what I did before, I'm going to define an area. This time I'm going to grab a larger area. So I'm going to pick the bottom right hand corner and pull that out. I'm going to hit done when I have my area defined. And then once I have that area defined, I'm going to do a grid spacing of 3 inches. And then we can actually pick a benchmark. So I can do a scan next to the benchmark, and I can actually pick that benchmark in the point cloud. So you can see the level of detail there on the ground. So even some dust on the ground as well too. So I just pick the benchmark relative to where the scan was. And then that's going to place a plane at that elevation and compare it to that elevation. Next, I'm going to put in a 0.125 of an inch of a tolerance. So anything that's outside of that tolerance, it's going to turn red or blue. So if it's below our tolerance, it'll turn blue. If it's above our tolerance, it'll turn red. So once the analysis is completed, I can turn off the cloud, and I can turn off the grid to show you the heat map inspection. So again, you can see why our FL was having a tough time trying to pass. Again, you can see this dark or the light gray that's showing you that's our area that was within tolerance. Red is above, again, as I mentioned, and blue is below. And then we can also export this as a report as well too, and I can hit save. And then that'll actually create a report for me. So if I just jump to the folder where it exported out some of those parameters, so if I come over here, it'll actually export out a TIFF image. So I can actually import this into AutoCAD, for example, or I can bring it into Tekla to see my floor analysis. I can see some XYZ coordinates. I can see a XYZ and a point coordinate in a grid format for each of those sections, which I can actually import into my robotic total station into TFL. I'm also going to hit create as well too, and create a floor inspection folder. So if I click into the floor inspection folder, I can actually turn on my station to kind of see where my floor is relative to my scans. And again, I can hit on the Map Analyzer tool. And again, this will give me a lot more detail of what's actually happening here. So this is my zero or my benchmark that I picked. And you can see up here is my dash line where it's cutting across. If I switch it to a vertical crosscut section, again, you can see why we were having a tough time getting our FL to pass. We're going from a very high, which is the red, going down to a low, so we can see which way the floor is sloping in. If I'm coming to a horizontal one where I can see where there's a lot more gray coming through here, again, if you look at our exaggerated difference plot, you can see how well it matches our zero line. And again, this is an exaggerated view of the point cloud. So one of the other benefits we can do with this is we can go to points and polylines, and we can actually digitize around that high area. So we want to take this information now back to the field and be able to, I suppose, lay this out in the field. So maybe we're doing some tiling applications, or maybe we're on a project where we are going to put down, walls and things like that. And we are having these walls crossing these high points. We want to know where we can grind down that concrete. So I'm just doing a quick outline of where it is high. So you can see I'm just doing a quick ruler or pencil outline of that high area. And again, I don't have too much data down here, so I'm just going to close it off roughly. And again, I'm just going to do a quick outline around the section here. Double click to close. And once I have it closed, I can create. Now I just create a new object here called Object 25 on the left hand side. Double click to rename. So I'm going to call this outline. And then I can hit close. Zoom out a little bit just to kind of get a little bit more context. I'm actually going to turn on the point cloud as well too, and again just to kind of show you can actually see the point cloud sticking up through our reference plane, showing you that the floor is actually higher on the south side, and it's sloping in towards the center. Just to kind of give you a good overview of what's happening out in the field. So I'm going to go back to my outline here, and I'm going to export this out as a DWG. So I go export selection. Just going to come back here, create a folder, or sorry, I can save it as a DWG. I want to do selected geometries, which is my outline, which I've selected in my list view. I'm going to export it out as inches because I'm in inches, and then I can leave everything as is and then hit export. Now my outline is exported. Now I can come into TFL. So TFL is our field software for the robotic total station. And now I can import that area that I had the outline with the structural model in the background. So I can lay this out in the field. So if I come to my layer section in TFL, turn on all my layers, and you can see where the steel is relative to that outline area. If I come in here and just turn off my layers here quickly and do a quick zoom in and rotate around it. And if I go to our orbit view, you can see where we were on that floor relative to that point, and rotate around it. Maybe I want to isolate this area out here now. So again, I'm going to go to my layers. I can select the line. It highlights it in my layer view, and I can turn off everything else. And now I can come into create from model, because I want to put X, Y, Z coordinate points on this, so I can actually lay it out in the field. And I can just do the multi-select window too and draw around or click, as you can see here, on our areas where we have an endpoint on this polygon. I can just do a couple here. And you can also create this on our Trimble Field Points Creator, where you can follow patch. So if you didn't want to do this on the field tablet, you can do it automatically. But this is a pretty simple area for me to do. But I can just click on this point here now. It's a 127. and you can see that each of these individual points has an XYZ coordinate that's relevant to my job site. And again, I can turn on my structural steel, and you can see exactly what we have in the model. So I suppose the last thing I want to do is take one final quick look, and you can see where the points are relative to my model. And I can switch to a wireframe as well too if I had some walls or more architectural stuff in our 3D model. So finally, before I hand it back over to Lee, I'm going to export out the point cloud as an E57, or I can export it out as a recap file directly from RealWorks. For this example, I'm going to do a E57 because I'm going to give Lee the point cloud where he's going to bring this into Trimble Connect to show you how you can do like the collaboration between your 3D model and the point cloud, and how you can share this as a project. So I'm going to create the folder here called point cloud. Going to that's the recap file. I'm going to select an E57, call it all points, and then leave the default. I want the color to come through as well too, and the intensity. Hit save, and then in a second or two that point cloud will be exported out from Trimble RealWorks for Lee to bring into Trimble Connect. So I'm going to hand it back over to Lee, and any questions you guys can let me know. Thanks.
All right, thanks, David. So here's a look at Trimble Connect Desktop. This is Trimble Connect that David was just referring to. This is a product that Trimble offers for communication and collaboration within the construction industry. We do have a free offline version of Trimble Connect, which is what I'm showing here, that you can use this functionality if you want to collaborate and communicate, or a myriad of the other things that Trimble Connect is able to do. You can go ahead and check that out online. But what I'll do is just come over here to this point clouds icon, just like we saw in Tekla Structures. Here it gives me a few options of how I can interact with the point cloud once it's inserted. And I'll just come up here and click add. You can see here's this E57 file that David just exported. If I hit the drop down, you can see these are all of the different file formats that we can insert into Trimble Connect Desktop. This matches what we can do within Tekla Structures as well. So I'm just going to go ahead and click on open and let this begin converting and inserting into the model. So it won't take too long to load. While it is loading, I'll just go ahead and mention some of these other things, and then I'll show them once it's inserted. Here you can adjust the thickness and the strength here within the point cloud file. You can also adjust the size and the density. And then we have various coloring options of how you want to be able to view this, whether by the default, the colors that were included within the point cloud scan, by elevation, which I'll show here, and then also any classifications if those were included. Alright, so now that that's been inserted, let me come over here to the model again for clarity. Let's just hide this guy here so we can see that. I'll come back to the point clouds here. Again, like I said, we can come in and start interacting with this. So some of these features and functionality not available in Tekla Structures, but that you can come in and use within Trimble Connect Desktop. For example, if you wanted to come in and start adjusting the thickness, for example, you could do that. Adjust the strength just by moving up and down these sliders, the size of the points and the density of the points, if you want to make that really dense or scale that back. However you want to be able to use and interact with those for various viewing options. Alright, we can also come in and color this. So for example, if we wanted to color this by elevation, just kind of give us an idea of what's going on here, we can view that in this way. And then of course, using the sliders, we can adjust that. For the classifications, I don't have any in this particular project here, so just for the time being, I'm just going to view the defaults. Again, if I come back and toggle in the model, I can view that in relation to the point cloud. I can use clip planes. I can come view this in individual plan views or elevation views. I can pull dimensions, and I can just use this to interact and share with my information. And one of the really powerful things about Trimble Connect is the ability to share information and to view information without being in the authoring software. So you don't need a modeling license, you don't need a RealWorks license to be able to view. If you just want to view, communicate, and collaborate, Trimble Connect is a great platform to be able to do that. So we'll start to wrap up here. If you're interested in learning more about the scanners or any of the solutions that are offered by our field technology group, such as RealWorks or Trimble Connect, you can reach out to your local building point. They'll be local there within your area. If you're going with MEP systems and want to reach out to our direct team, you can see the information that's there as well. And then if you're interested in learning more about Tekla Structures, you can go to tekla.com/US for the US website and get in contact with us there. We put a lot of work in trying to keep everybody up to date with new things that are included into the Tekla software. So if you're interested in following that, we have YouTube channels that you can subscribe to for tips and tricks, recent steel developments, recent concrete developments, and that sort of thing. There's a video specifically about the point cloud functionality that was released in version 2018 if you're interested in checking that out. Definitely just subscribe to those channels and then you'll get an email each time that we upload new information. So that's it from us today. We definitely appreciate your time in watching the webinar today. If you send in any questions that we haven't answered yet, we'll be sure to reach out to you after the webinar to answer those. And we hope to see you again in a future Trimble webinar.